Hello and welcome to the first of several videos that I intend to make for you to help review for the Regents exam towards the end of the year. Now these videos are not going to be intended to recover all the things that we learned this year, okay, but I really want to focus on the most important topics in parts of each particular unit we learned. Before we actually get into specifics for the Unit 1, I just want to go over some things about these videos in general. First, I tend to organize them in a way that hopefully will be helpful for you. Okay, I'll start off with giving a brief overview first of all the lessons that we have learned in this particular unit. Then I actually want to take a few moments just to briefly discuss the specific learning standards that are associated with this unit. And these standards are used to create the Regents exam questions. And then I'm going to take a few moments to go over some basic terminology, some really important terminology that's introduced in that particular unit. And if there were any formulas that were introduced, I'll take some time to point those out, specifically the ones that are given to you on the reference sheet versus the ones that you have to memorize. And then I'll get into specific topical reviews, different elements within that unit that were very crucial. Now, you may feel like you understand a lot of things that are going on in this particular unit or whatever video we're watching, so feel free to fast forward to the parts that you want to focus on by referring to the headings. Each of the headings up here in the videos will be the title of that particular part of the review. So feel free to fast forward to the parts that you want to focus on. Also, I encourage you to pause the video, because what I really suggest you do with these videos is to start creating a notebook or some kind of study guide for you, okay, so that you can have all the information condensed into one location. Of course, keep your notes with you, because those are going to be more comprehensive, okay, to refer to, but it's good to have a nice study guide, and this might be a good way to do this, because we'll have a terminology section in each of these, a formula section, and specific topic reviews. Okay, so feel free at any moments during this video to pause and write down anything that you want to in your study guide. Let's look at Unit 1. Unit 1 is the Algebraic Essentials unit. Okay. So in this video, go over the lessons that we encountered. I'll also point out the 3 standards that were used in this unit, talk about 4 slides of basic terminology, and then the topical reviews I'm going to focus on are the real number properties, solving the linear equations, basic exponent properties, multiplying polynomials, a word on calculator use, and at the end I'm going to summarize the most important things of this particular unit. So first, here are the lessons that we had. So you should have notes for 1.1 through 1.6, and these were the lesson titles. Notice 3 of the units. These are the Common Core standards that are addressed in them. Especially in the first few units, they're more introductory and you're learning a lot of crucial things that are used later on in future units. So you're not going to see too many Common Core standards in the first few units because these are really just setup units. Okay, so let's go on to the Common Core standards. Now, a lot of these standards are going to be used throughout the entire curriculum, and they're going to be revisited in different units. But in this particular unit, we created equations in one variable, and we used them to solve particular problems. Later on, we dealt with quadratic functions, but in this particular unit, we looked at linear functions. And we saw a little bit of introductions to exponentials, absolute value, and rational functions. We also looked at exponent rules to write expressions involving radicals and rational exponents using the properties of exponents. Now, of course, we didn't really look at radicals and rational exponents. We really looked at integer exponents in this particular unit. But as you know, in future units, we looked at rationals and radicals. And then we began to see how structure can be seen within a problem to identify ways to rewrite it to help solve a problem in an easier way. Okay, so let's get into the basic terminology. Now, these are all crucial terms that you should be very familiar with, and if not, make sure you write them down and become familiar with them. The first term is variable. A variable is just a quantity that is represented by a letter or symbol that is unknown, unspecified, or can change within the context of a problem. Typically, we think of variables like x, y, z, or we think of maybe letters like a, b, c. Okay. Those are all going to be variables. Now, in equations, they're unknown because they actually have values assigned to them, but we just don't know them yet. Sometimes we assign variables to help quantify something that we're looking for to set up an equation. And sometimes they change depending on the context of the problem. Term. A term is just a single number or combinations of numbers and letters, variables, that only deal with multiplication and division. So those just essentially monomials. So 3x squared y is a term. 5x is a term. Negative 17 thirds y cubed is a term. Only multiplication and division. Expressions are formed by combining terms using addition and subtraction. So then we have things like 3x squared y plus 5x. Then we get an expression. And an equation is a statement where you have two values. The values of two expressions are equal, indicated by an equal sign. So you'll get things like 3x squared y plus 5x is equal to 0. Now it's very, very important that you understand the difference between expression and equation. Very often people get these mixed up. Expression, no equal sign. Equation, equal sign. Okay, so if you're asked to simplify an expression, you'll never have an equal sign. If you're asked to solve an equation, you're always going to have an equal sign. Okay, now within expressions, you have things called coefficients. Coefficients are essentially the numerical value preceding a term. So if I had a polynomial like 2x to the 5th minus 7x to the 4th plus 3x squared plus 5, the coefficients are going to be the numerical numbers in front of each term. So the 2, the negative 7, the 3, and the 5. Those are all considered coefficients. Like terms is one you've been very familiar with. It's just essentially any terms where all the variables had the same exact exponent powers. So 2x and 5x are like terms. 3x squared y and 7x squared y are like terms. They have the same variables, same exponents. However, 3xy and 5xz are not like terms because they don't have the same variables to the same power. And 0 is just essentially a numerical value that when you substitute into an expression, notice expression, not equation, that provides a value of 0. So, if I have the expression 3x plus 15, the number that I substitute in to make that a 0, to make that equal to 0, is negative 5. So negative 5 is considered the 0 of that expression. Okay, and these are some terms you're very familiar with. Monomial, it's an expression with one term. Binomial, 2 terms. Trinomial, 3 terms. And we didn't really use this term, but quadrinomial is a way you can express an expression that has 4 terms. Okay? And remember, a term can have multiple variables in it. It's just one thing with expressions, with multiplication and division. So 3x is a monomial. 3x plus 5y is a binomial. 3x squared minus 15x plus 7 is a trinomial. And a quadrinomial would be 4x cubed plus 7x squared minus 5x plus 10, for instance. That's a quadrinomial. There's 1, 2, 3, 4 terms separated by addition and subtraction. Now, I gave some examples where they had decreasing exponents, but of course, you can have any three terms. So for instance, a trinomial could be 3x squared y plus 5xy minus 7. That is three terms. 3x squared y is one term, 5xy is another term, and negative 7 is another term. Same thing goes for quadrinomial and binomial. Okay, and there's some terms that were used to refer to expressions or equations. So this is going to work for both expression and an equation. And specifically linear, quadratic, cubic, and quartic we've kind of seen a little bit. Not in this particular unit, but we saw quartic before. Linear just means that the highest exponent of one of the terms is a 1. So an example of linear expression might be just 5x. Or 5x minus 2. Those are two linear expressions because the highest exponent is a 1 on both of those variables. Now for quadratic, the highest exponent is going to be a 2. So an example of a quadratic would be 10x squared. Or negative 2x squared plus 7. Okay. Now notice these could also be equations. A quadratic equation is one where the highest variable has a 2, an exponent of a 2, but it has an equal sign. So 5x squared minus 3 equals 10. That's an example of a quadratic equation. That's an equation, and these two are going to be quadratic expressions. Okay, so cubic has the highest exponent of a 3, quartic has the highest exponent of a 4. And we've also seen quintic before. Okay. So now let's get into some topical reviews. The real number properties. Now these are properties that are kind of used to justify steps of solving an equation or why you can arrange expressions and terms and variables in certain ways. And they're important to know because you might be asked to justify your steps in solving an equation or to state why something is true. Commutative property applies to either addition or multiplication. Now when I say addition, that could mean subtraction, because subtraction is really just addition with negatives. Multiplication also refers to division, because division is really multiplication of reciprocals. Now the commutative property means that if you have two things added together, A plus B, that means I can commute the terms, meaning move them to B plus A. I can switch it. Commute means to move. They move places. Multiplication, if you have A times B, you can commute them, switch them, by making B times A. Now notice if you did this with subtraction values, if you do A minus B, that's really equivalent to A plus negative B. So that would commute to become negative B plus A. So you have to be really careful about commutative property with things dealing with negatives. Likewise with multiplication, if I have A times 1 over B, that's going to be the same as 1 over B times A. Commutative property. The next property was the associative property of addition and multiplication. The associative property, associating, means you're changing where the parentheses are in the problem. You're associating different terms with each other. So if you had something like A plus B is added to C, what you can do is you can associate those parentheses with different variables. So you can change them to run the B plus C. So you can change this into A plus B plus C. Nothing is moving around other than the parentheses. The variables are staying in the exact same location. So they're not commuting. They're being associated in a different way. Multiplication, same thing. A times B times C can be associated in a different way where you can have A times B times C. You're just changing where the parentheses are. The order of the letters and variables stay exactly the same. Okay, distributive property. Now, distributive property is also thought of sometimes as in the terms of factoring. Okay, that's going backwards with the distributive property. Okay, because the distributive property says that if you take a quantity of multiplication and division, so you're multiplying two quantities together, over addition and subtraction, means you have two things being added or subtracted. What that's saying is you can distribute this A that you're multiplying with the B plus C to both the B and the C. So it becomes AB plus AC. Notice if you were to factor out an A from both of these terms, from that binomial, that would bring you into the form A times B plus C. That's also considered the distributive property, even though it's kind of going backwards. It's reverse distribution. Okay, now you might be wondering, what's the important thing? Why do you need the commutative, the associative property? Well, really it's because addition, subtraction, all the operations are always between two quantities. So if you're multiplying three things together, like with the associative, you're only multiplying two things together at a time. So A times B is multiplied together to give a quantity, times C is really the same thing as A times the quantity of B times C. Now let's look at solving linear equations. There are three situations that you incur with linear equations, and with other types of equations too, but we really focus on linear equations in this particular case. When you have one solution, it's essentially going to happen when you have, in an equation, both sides have different coefficients in front of the x. So if I see something like this, 2x plus 5 is equal to 5x minus 10, that's in simplest form on both sides, all like terms are combined. The 2x and the 5x are different, have different coefficients, meaning if you were to solve this further, okay, then you would have one solution. Identity and inconsistent equations occur whenever you have situations that have the same coefficient in front of the x. Okay, so if I got something like 2x plus 5 is equal to 2x plus 5, notice both the x terms have the same coefficient. And if you were to solve this equation further, this is called an identity because you get something that's true. 0 is equal to 0. Subtract the 2x from both sides, subtract the 5 from both sides. So you would have infinite number of solutions. In other words, the solutions are all real numbers. Okay, infinite solutions. Any value of x you plug in will work. And that's due to the sole fact that 2x plus 5 is equal to 2x plus 5. No matter what you plug in, it will work. Now, inconsistent equations also have the same coefficient. However, they're going to have a different numerical value. So, like the 5 would be in one equation, but you'd have maybe a plus 7 in another. Now, if you were to solve this equation, subtract the 2x from both sides, subtract the 5 from both sides, you get 0 is equal to 2, and that's a false statement. So this type of an equation has no solutions. There are no values of x that will ever make this a true statement. Real or imaginary doesn't matter. There's no solutions at all. That's why it's inconsistent. Okay, so just to recap, one solution if you have, in simplest form, different coefficients in front of all the variables. And if they have the same coefficients, you just have to see if they're exactly the same thing. It's an identity. And if there's slight difference in the other parts, namely the numerical terms, the constant terms, then it's going to be inconsistent. The basic exponent properties, we looked at some more complicated ones in the future with rational exponents and radicals. But in this particular unit, we focused on what happens when you multiply expressions with common bases. So 5x squared y cubed times 20x to the 4th y to the 10th. Okay, and when you multiply expressions that have common bases, what we did is we added them, the exponents. So the coefficients, the numerical ones just multiply like usual, so this becomes 100. The x to the second times x to the fourth becomes x to the 2 plus 4. And the y's to the third and y to the 10th, when you multiply, becomes y to the 3 plus 10. You add the exponents. So your final answer in this case, in this example, is 100 x to the 6th, y to the 13th. So when you are multiplying expressions, you add the exponents on common bases. Dividing expressions, you're going to subtract the exponents on common bases. Okay, so if you had something like 20x to the 4th, y to the 10th, divided by 5x squared, y to the 3rd, same example. Just I'm going to divide them rather than multiply them. Numbers divide the same way. 20 divided by 5 is 4. X to the 4th divided by x to the 2nd becomes x to the 4 minus 2, the top exponent minus the bottom exponent, and y 10 minus 3. So that simplifies into 4 x squared y to the 7th. And raising an exponent to a power, say I have 5x squared y, and I raise it up to the 3rd power. What I do is I raise every single term in that particular expression, that monomial, to that same power. So that's going to be 5 to the 3rd, x squared to the 3rd, and y to the 3rd. Now when you raise something to a power, you multiply the exponents. On the variables. Now 5 to the 3rd, 5 times 5 times 5 is 125. X squared to the 3rd, 2 times 3 gives you 6. And y to the 1st, essentially, to the 3rd becomes y to the 3rd. So you multiply the exponents. Oh, let me go back. Okay. Now one thing that I want to point out, though, specifically with these raising the exponents to a power, is don't fall into the trap of like x plus 2 squared. That's not equivalent to x squared plus 4. Okay, and we'll get back into that in the next part, which is talking about multiplication. Okay. So multiplying polynomials, there were really two methods that we used to multiply polynomials. One was distribution, one was the Punnett square method. Okay, and it's very important to note that you can only multiply two polynomials at a time. The operation of multiplication always connects two quantities together. Never three at once, only two at once. The distribution method, so if I took the multiplication of polynomials, such as maybe x plus 3 times x minus 4, what I had there in the distribution method is I took the first term and I distributed it to each term in the second polynomial, giving me x squared minus 4x as my first two terms. Then I took the next term of my polynomial and distributed it to the two terms of my next polynomial, leaving me with plus 3x minus 12. And then you just combine like terms. So it gives you x squared minus x minus 12. That's the distribution method. The Punnett square method, I put square in quotation marks because it's not always a square, and it always bugs me that it says square, because it could be a rectangle, is you set up kind of a rectangular array where the rows and the columns are going to be each of your terms. So if you have x plus 3 times x minus 4, then x plus 3 goes either in your columns or rows, and the x minus 4 goes to the other place. Okay, and you just multiply it just like you would any kind of times multiplication table. X times x makes x squared. 3 times x makes 3x. Negative 4 times x makes negative 4x. And then negative 4 times 3 makes negative 12. And you combine like terms like you did with the distribution. Then you have x squared minus x minus 12. Now when you multiply 3 or more polynomials, then you just have to group them. You're going to multiply two things at once. So if you had something like x plus 3 times x minus 4 times x minus 3, the way you're going to do this is you're going to group two of them together. It doesn't matter which two you group together. Typically it's maybe the first two, or you can group the last two, or you can group the first and the last. Okay, it depends which is easiest to solve this particular problem. Okay, but you'll always group them by 2, multiply those two together. As we saw up above, this would give us x squared minus x minus 12. And then we multiply that with our next polynomial. And just a word about calculator use. Okay, when to use parentheses. And you're essentially going to use parentheses when you are evaluating expressions. Typically, whenever you're using division, especially when you have a binomial on the top or the binomial on the bottom, it means something like x plus 3 over x minus 4. If you're plugging something in with the calculator, you put the parentheses around the numerator and the denominator before dividing. So your calculator should read x plus 3 divided by x minus 4. Okay. And when you are also multiplying and dividing, any kind of operation that's dealing with division, square roots is another common one. Okay, your calculator luckily starts with parentheses for you in that case, but just be careful. And anytime there's also parentheses in the problem, it's never a bad idea to put the parentheses in the calculator. Now the store button can be helpful if you want to evaluate a long expression. What you can do is on the bottom you see the store button STO with an arrow. That means if you type in that, so if you get an answer, okay, say your calculator gives you 35.2159276, and you don't want to keep typing in every time. What you can do is you can press that store button, which will give you this. And you can store it as any variable you want. You can hit alpha A, alpha B, you can hit just the X button. So that every time you type in that variable in the calculation window, it'll give you a substitution of what you assigned it to. Okay. So every time I type in X in this case, it would assign it as 35.2159276. So it makes evaluating, checking your answers to expressions like 3x squared minus 5x over 2x plus 7 a little bit easier. You have several x's in that particular problem. You just type this in with the parentheses where they're supposed to be, divide it, and then if it gives you the same exact value of what it says it's supposed to be equal to, then you know you solved for the variable correctly. Okay. And tables, you can use tables to check your work, and especially when you're simplifying expressions. So in y1 you might put the original expression before simplifying, and then maybe in y2, okay, you put your simplified expression. Now if you hit second graph, or get the table of values, if you get the exact same values in both the y1 column and the y2 column, if these are the same across, then you know that you simplified your expression correctly. You can say with a certain degree of certainty that you are correct. Now these techniques are essentially useful in your calculator to help check your work, okay, and make sure you're plugging things in correctly. Alright, so let's look at the summary of the most important information from this particular unit. And I'll phrase these in terms of what you should be able to do after this unit. Okay. What you're supposed to be taking away from this unit. First thing is, you should be able to know the difference between an expression versus an equation. Expressions have no equal signs, equations have equal signs. Secondly, you should know, identify, and be able to apply the three properties of equality of real numbers in this unit. Okay, commutative, associative, and distributive. Be able to identify them, know how to use them, justify steps using those properties. You should be able to solve linear equations. That's a pretty easy thing, but you also should be able to identify the linear equations that are considered identities and those that are considered inconsistent. You should be very familiar with the basic exponent properties, specifically multiplying monomial expressions. You should be able to multiply two or more polynomials using either the distribution or the Punnett square method. Now, one note about this is the distribution method, if it says to multiply them algebraically, that's really the method that is being sought. Okay, algebraically means distribution method. Punnett square is a more of a visual method. It's still kind of algebraic, but it's not really the algebraic technique. Okay. And then lastly, we looked in this unit and how to use a calculator to help verify your solutions to an equation or to verify the results of an expression after simplifying it. Now, I know this video is long, and I'm going to try and make the future videos a little bit shorter, but hopefully this was a nice little review for Unit 1. See you in the next video.